So, what are you doing here? I mean, it was pretty clear in the abstract, right? Don't go to this talk. Well, since you're here anyway, a little bit about me. I'm Jan Ouwens. I work for CodeStar, where I do mostly Scala development, lots of fun. You can follow me on Twitter. And that's a picture of me in a dress suit with a sombrero, which I think is a good metaphor for this talk. So people might know me from Equals Verifier. That's a project that I work on. And you can use it to test your equals methods. It tests the whole contract of equals, and it does that in just 2 lines of code. You can imagine that below the covers, lots of dirty tricks are going on to make this all possible, and that's true. So while I'm debugging issues in Equals Verifier, I have come across lots and lots of interesting corner cases, let's call them interesting, in the JVM and in Java. And in this talk, I'm going to share them with you. So these are just, small things that can trip you up if you're not careful. And I'm going to show you how you can turn them into weapons. All of this is to annoy your colleagues tomorrow when you go back to work. So I have divided the things that you can do into 4 different topics that you should definitely not be messing with if you know what's good for you or your colleagues. And these are the 4 subjects. Every hack that I'm going to present, I'm also giving it a rating, a 3 emoji rating, where 1 is the not so bad, it's a little annoying, but it's not so bad, and 3 emoji is the worst of the worst. So let's dig into the first subject, the language features. I'm using the term lightly here. So everybody here, I think, is familiar with Java 8 by now, right? Show of hands, please. That's almost everybody. Good. So as you may know, in Java 8, lambdas were introduced. But I think a lambda is not truly a lambda if you don't call it lambda. So this is a thing that you can do in Java. And as you can see, it actually works. So that's a nice trick that you can use. As you also may have noticed, this program is running on Java 11. Who of you is familiar with Java 11? Significantly less people. Very interesting. As you can see, there's a var in here. And I've put it in to convince you that all of the hacks that I'm going to show you this evening are actually still working on Java 11, despite the module system and everything that they made impossible. All of these things are still working in Java 11, so don't worry if your team has already upgraded. As a sidebar, briefly, another way to annoy your co-workers is to install weird color schemes in your IntelliJ, as I have done, as you can see, or use the NyanCat plugin in IntelliJ, which turns every progress bar into a NyanCat. If you pay attention, you will see it when I run my demos. Or also a nice one is install the Vim plugin in your IDE. That makes it impossible to pair program with somebody who's not familiar with Vim. Great fun. Okay, so let's go to the next one. Because if you are using Unicode in your Java identifiers, let's take it up a notch. Can you do Zalgo? And in fact, you can. If I run this program, it just works. And as you can see, it even works with reflection. You have to take care to copy-paste the code, obviously, because it's kind of hard to type. But it just works with reflection. So that's pretty cool. I'm giving it 1 emoji, because we're just getting started. More fun stuff is coming up. But it's hard to read, hard to type, therefore fun to annoy your coworkers. Okay, the next one. False is true. So here's a test that asserts that the string false is equal to the string true. Who thinks this test will fail? Okay, I see some hands. Who thinks it will pass? Well, that's already quite a lot less hands, but still some people who are suspicious of the code. So actually the test passes. And why would that be? Would it have something to do with the suspicious comment? I see some people pointing. That may be because they see some text over here. But really, there's nothing to see here, right? Okay, let's scroll a little further. So who remembers this trick from their Oracle Certified Java Programmer training? What happens here is that the parser, the Java parser, interprets the Unicode escape sequences before it actually looks at your code. So I have inserted the new line Unicode symbol here, which means that Java actually sees a new line and executes that if return, the if true return statement. I had to include the if true because otherwise IntelliJ would catch on, because it's apparently a little bit smarter than Java is. But just to prove that I'm not speaking nonsense, I'm removing the comment, running it again, and now the test fails, as you would have probably wanted. So this is a great way to fix a flaky unit test. So a couple of years ago, there was this new language that came out called Scala, and it said that it was a better Java. Some people may think that's correct, some people may think it's not, but let's see if in this instance it's better. Because what happens if I do the same thing in Scala? Who thinks the same behavior as in Java? Show of hands. I only see one hand. 2, 3. Okay, who thinks it's fixed in Scala? Who is afraid to raise their hands? Right. Okay. So if I run this, the behavior is indeed the same as it was in Java. So that's kind of disappointing. But a few years after Scala, there was this new language called Kotlin. What do you think? Did it improve over Scala? Oh, lots of hands, lots of hands. Who is very jaded and thinks, no, it's still there? Most people think it's still there. Well, let's have a look. In fact, they fixed it in Kotlin. So everybody go to Kotlin and pay attention for the coming hacks, because most of them also work for Kotlin. Okay, so this is, as I said, a great way to fix a flaky unit test. So therefore, I'm giving it 2 emoji, because you can seriously mess up your code base like that. Yep. Okay, so if we do this Unicode escape sequence thing, let's see if we can take it to the next level. I have a little program here. It contains a string that also contains a little program. And the program converts the string into Unicode escape sequences. So I'm going to copy-paste this over here. Open up my terminal. Paste this in here. And if I run that, it works. And the cool thing is that Maven doesn't care about this. If you put a Java file with only Unicode escape sequences in there, Maven doesn't care. IntelliJ does care, so you have to pay attention to hide it properly. But you can use this to do something funny, if you like. Just removing them again. Okay. So this trick is a lot harder to type and to read. Maven doesn't care about it, so again, a great way to hide some malicious code. And maybe some of you have seen the Java magazine. Yeah, a lot of people. There is actually an article in there that's based on this talk, basically, and it has a different kind of program hidden inside the Unicode escape sequences. So if you want to have fun, just type them out and see what comes out. You'll be surprised. I promise it won't break your computer or anything. Okay, so we can use Unicode. Unfortunately, we can't use emoji in Java, but we can use them in Scala. And that's also a nice way to make your code kind of hard to read. I've already hidden an implicit in there, so it was already kind of, out there, but it does work. Hello, JFall. An emoji operator, yeah, maybe I should have done that. So I'm rating it 1 emoji, but it looks very festive, right? So I'm using this one. And actually, in the program booklet from JFall, they redacted out the emoji. I don't know why they did that, maybe to hide the fact that something suspicious is going on in this talk. But we all know what's going on. Okay, so the hash code. I have here a little program or a little function that can calculate a string based on another string that has the exact same hash code of the input string. So if I run this program, you will see there's 2 very different strings and they have the same hash code. So that's kind of fun. I won't bore you with the implementation. Everything is on GitHub. I will show you the link at the end of the talk, so you can download it and play with it yourself. But what's the point of using an algorithm that can change a string and produce the same hash code? Well, it's mainly interesting when you have an inexperienced coworker who insists on using hash codes as the keys in collections, because then things might not work out the way you expect. But that's not really a very common thing. Fortunately, a year and a half ago, more or less, some people discovered that during the Dutch elections, they also calculate hash codes to see if a ballot is the ballot that it was supposed to be. And it turns out that they were able to create different ballots that have the same hash. And in theory, you could influence the elections that way. So I don't know if there's any Russians in the audience today. Okay, so that was it for the language features. Let's talk about reflection a little bit. And to do that, I have written a small library that I'm going to be using throughout this talk. It's really very simple. The only thing it does is that it wraps the existing reflection calls from the Java API, but it adds a set accessible true. That makes my code a little bit shorter, so I can show you the examples in less time. But I want to show you this, that I'm not doing anything fancy. It's just regular JVM stuff. So the first example. This is a program that prints the integers 0 until 9, but it also changes the value of the integer 5. So who thinks it will print 0 until 9? Nobody. You've been paying attention very, very well. So anybody has an idea what does happen? I hear lots of murmuring, but no. Double 4. I hear a double 4. You're close, but not quite. Infinite 4, exactly. So if I run this, I get into an infinite loop of lots of 4s. And why this happens is because Java caches these integer values, not the int, but the integer, the boxed ints. So if you take 5, you take the value for 5 out of the cache, then you change its internal value to 4, and inside the cache, the 5 is now 4. So in the loop, when you add 1 to the value 4, it says 5, so it takes 5 out of the cache, and 5 is now 4, so you have 4. Then it adds 1, so then you're back at 5, and it finds 4, and it goes on and on and on. So if you have a coworker who insists on using boxed primitives in their code, this is a way that you can mess them up. Lots of fun. So who thinks this was not a good idea to put into practice in production code? So that's almost everybody. I'm glad to see that. The reason why you don't like it is because you have an expectation that this value will stay the same throughout the program. And if it suddenly changes, well, you don't expect that. So you don't do anything to counteract it. However, we are quite used to this problem in the JVM because we all know calendar and we all know arrays, and actually most of the collections also work like this. So who thinks those are evil? Yeah, a couple of hands. You must be Scala or Kotlin developers who are used to immutability. Yeah, but it gets even worse because JPA, anybody? Those things are mutable as hell, This is really no fun anymore. If you're not careful, you can just change the database value that way. So I'm going to give this 3 emoji, the maximum score. Okay. I have another little program. It prints out 2 strings, then it changes one of them, and then it prints out the world variable, which contains at the beginning of the program the word hello world, and it also prints the literal once again. So the bit of reflection, what it does is it takes this world variable and it changes its inner value to whatever is in the jfol variable. So probably the second block of printouts, the first one will print hello jfol because we did this reflection thing. Who thinks the second line or the final line will also be still hello world? Hands, anybody? Only a couple. Who thinks it will be something else? You're smart people. So if I print this, then at first you will see hello world, hello jfol. Then you see a bunch of warnings. And then you see hello jfol 2 times. And this happens because in a class file, a compiled class file, every string literal will be used only once, and then when you use it again in the same class, the class file, the bytecode, will refer to that one instance inside the class file. So you can even change literals that have nothing to do with the thing that you're changing, or so you think. And that, again, is a nice way to mess up unit tests with lots of magic strings. But how about that warning? That's kind of annoying, right? If you see that in your build logs, then some warning flags will go off at some people. No, maybe not. But if you want to be super sure that nobody notices, in Java 9 and up, you can add this thing. Oh, what's going on? What's going on? I'm just trying to select this. Okay. And then put it in the configurations like this. It's a JVM option. Apply. Okay. And if I run it, then the error is gone. So again, just to show you, even with the module system from Java 9, you can still do nasty things without people noticing. There was some talk of disallowing this in a future version of Java, but it hasn't happened yet. I'm not sure if it will ever happen or anytime soon, so you can still do this. Okay, so this intern trick is kind of fun in unit tests, where you have lots of magic strings. If you want to teach somebody a lesson, then you can use this. I'm giving it 2 emoji. Okay, so the next thing is check style. Who loves check style? Oh, not many people. Yeah, you get a lot of warnings in your code, right? So I have here a little program that also has a check style warning in it because I'm not using the proper naming conventions. Now, this is a very simple example, but you all probably have been in a situation where you had to fix cyclomatic complexity warnings, right? And those are super annoying. So there is a way to avoid all of this. So what I have here is a string. It contains the same program as before, but now inside of a string. And what I do is I use the internal compiler to compile this string and turn it into a class file. Then I load it with a class loader. It's all written here. You know, you have to do a lot of things to make this work. But when you do, as you can see, the program prints. So if you have a check style warning and you don't like it, you don't want to fix it either, this is what you can do about it. Again, all of this is on GitHub. If you want to try it out later, just download it when you get home and have fun. I glossed over the code to make it work, but there's lots of dirty things going on. I did not call close on something that should be closed. I don't report compilation errors. I don't handle exceptions. You should probably be doing that if you put this in production. But that's not why we're here. Okay. Actually, since Java 9, we have multi-release jar files. Everybody familiar with this feature? No? The idea is that you have a jar file that should target, for example, JVM 8. But there is a more efficient or a better way to do it in a later JVM, like Java 9. And you want to use that code when you're on Java 9, but the original code when you're still on Java 8. Then you can use a multi-release jar file where you tell the JVM, well, if you happen to be running on JVM 9, then you can use this code, otherwise fall back to the original code. But if you are still on Java 8, or Java 7 even, if you're still on Java 7 and you want to be able to support things from Java 8, what do you do then? Well, you can use the same compilation trick. And in fact, in Equals Verifier, I have done this thing exactly because I had a bug report at one point where they said, well, this Lambda isn't working, but I still wanted to support Java 7. How do you deal with that? Well, obviously, you compile the thing if you're running on a JVM 8 and you use that in your unit test. And if you're not on JVM 8, well, then you just return early in the unit test. It has worked in production for many, many years, I can tell you. It works like a charm. It's great. So this is a great way to hide some code, again. Especially if you mix it up with the Unicode trick. Okay, so that's it for reflection. Let's talk about annotations. I think most of you are familiar with Project Lombok. Who likes Lombok? Okay, about half the room. Who dislikes it? More or less the other half of the room. So what Lombok does, and this is the reason why people often don't like it, is that it uses annotations to trick the Java compiler to do things that are not standard behavior. And this scares some people a little bit. And for good reason. I have a question at the front. Do I like it? Yeah, well, I usually use Scala, so I don't have to use it, but I don't know. I know that a lot of people don't like it. But there is a thing that is even worse than Lombok, people, because Lombok does this at compile time, but there are tools that can do it at runtime, which is even scarier. We call them Spring and Hibernate. This is horrible. But since you're all probably using this on a day-to-day basis anyway, I'm not going to spend any more time on it. So let's go into the fourth subject, the external libraries. And I have chosen libraries that are probably already on your class path, even if you don't know it, because they are dependencies of other dependencies that you use. One of them is Obgenesis. And Obgenesis is a library that you can use to instantiate an object without calling the constructor. That's the only thing it does, and it does it very well. This is, for example, used in mocking frameworks. So if you use a mocking framework, then you probably have Obgenesis. So as an example, here I have a class. It has a constructor. The constructor throws an exception. So, you cannot instantiate this object, this class. But it also has a toString method, and I would like, for some reason, to call this toString method. Can I do that? Well, yes, I can. I just use Obgenesis, ask it to create a new instance for me, and voila, I have a new instance, and it works. So that's pretty nice. But this is a kind of a boring example, right? So I'm just going to give it one emoji. But here's a nice thing. This is a quote from a very famous book. It talks about ironclad guarantees and sophisticated attacks. And this was the second edition, which came out, I think, before Java 6 came out. So it was kind of a long time ago. So I bought the third edition to see if it's still there, the quote, and it is. The third edition handles up to Java 9. So, if Josh Bloch says it, then it must be true, right? Okay, so what I have here is a singleton enum. And what I'm doing here is I have a function that says copy enum constant, and then it prints out the original and the so-called copied instance, and then it prints out whether or not the two are the same or not. And if I run this, it looks like they're the same, but they are not the same. So I have two instances of this instance enum, and that's not supposed to happen. How do I do that? Well, it's actually pretty simple. I create a new instance using Obgenesis. And then enums have two fields inside, the ordinal and the name. So the ordinal is the order in which they appear in the enum declaration. In this case, it's 0 because it starts at 0. And it has a name, which is obvious. So I just have to create a new instance of my enum, set the proper values, and return it, and I'm done. And that works. Super cool. So I'm giving this 2 emoji because a singleton should only have one instance. Really.
You can also create new ones at runtime and add them to the enum.
The guy at the front says you can also create new ones and add them at runtime, which is indeed what I'm going to show you now. So I have a confusing card game. In France, you can buy tarot cards, which are not used to predict the future, but actually to play a game. And the difference with regular cards is, the main difference is that they contain a 5th suit, which are the trumps. So if I want to do something like that in Java with an enum, I define my suits, the diamonds, the clubs, the hearts, the spades. And I can just add a constant if I like. And to show you that that works, I'm going to iterate over all of the values of the enum. Then I'm doing my little magic, and then I'm going to iterate again to see if there's a difference. And as you can see, the first time it runs, there's only 4 of them. Then we get the error again. You know how to disable it. I'm not going to do it right now, but... And it actually works. I have now 5 elements in my enum. So it takes a little bit more work to get this done, but it's actually not that hard if you read the code. The first thing that we do is we fetch the values of the enum, the original values, and we also need the length of that array of values. Then we create a new instance. The ordinal will be the same value as the length of the original array because we have 4 values in there. It starts at 0, so the length, blah, blah, blah. We set a name that we choose. In this case, we use trumps. And then we create a new array, which contains the original values plus the new one. And then the final trick is, and this is something that I had to puzzle over a little bit, an enum has a values function that you can use to fetch all of the values, and this is backed by an array which has the name $values in all caps. But this field is actually static and final, so we have to use reflection to remove this final flag, or otherwise I cannot change it. I see a question in the middle. How magical is the actual implementation of OpGenesis? To be honest, I'm not really sure. I know that it has several strategies to do what it does, and depending on which JVM it runs on, it chooses one. But I'm not sure about the details. Anyway, this is a fun little trick that you can use. So I'm going to give this tree emoji because this is really not supposed to happen. And because it is so bad, I'm also giving it... It's about Trump, right? Okay. So another external library that you can use, which is a lot of fun, is ByteBuddy. Anybody familiar with ByteBuddy? I see a couple of hands. Okay, so for those who aren't familiar with it, ByteBuddy is a library that you can use to generate Java bytecode on the fly at runtime. And I'm also using ByteBuddy Agent, which is an extension to ByteBuddy with which it is easy to create agents. And does anybody know what agents are on the JVM? Again, a couple of hands. So just a short explanation is an agent is a Java program that can connect to a running JVM and do stuff there. And now you think, well, that's kind of scary, but there are many legitimate use cases for this. For example, debuggers use this. Profilers use it. Measurement instrumentation tools use it. And they all need to connect to a running JVM to do the thing that they are built to do. And we think these programs are very useful, and in fact they are, but you can also use them for evil. So this is something that I learned from a former colleague of mine. I'm not sure if he's in the room today. He was at the conference. But here is a little program that prints out the current time millis every second, but after a couple of tries, it travels through time. So let's see what that looks like. You know, big, long integers. And then suddenly, -1, -1, -1. Okay, so how does that work? I'm using ByteBuddy here. So first I install the ByteBuddy agent, which is just a little helper. And then I redefine the system class, specifically the method named currentTimeMillis. I intercept it and make it return the value -1. Then I build it, I make it so that I have bytecode, and then I load it using some class loader. And now I can replace, using this agent, the existing implementation of the system class. So the idea for this is that if you have some legacy code that uses currentTimeMillis and you want to test that, but you know the thing keeps updating itself all the time, which is super annoying if you want to write a unit test, then you can just replace it with something that returns a value that you expect, and then you can write your unit test. And this is in fact how it was originally intended. But obviously you can use it to change everything into anything, which is fun. So I'm giving this tree emoji. This is really super dangerous. Let's take it one step further, because what I have done here is I have changed a system class in a JVM that I was already running inside of. But I can also do this with a JVM that's running somewhere else. So I have a victim class over here. What it does is it basically does the same thing as the previous one. It prints out the time every second. And it also prints out the current process ID, because I'm going to need that in the attack program. And what does the attack program do? It has a main method. And when I run the program, the main method is executed. And the main method, what it does is it attaches the ByteBuddy agent to the JVM that is connected with a certain process ID. So this is where I need the process ID. And what it connects, the thing is, I have to specify a jar file that contains the agent that I want to run on the other JVM. So the second part of this program is an agent main method. And agent main is a special method in the JVM, the same way that the main method is special in the JVM. And that's what you can use to define your agent. The program does basically the same as the time traveler that I just showed you before. Also, just to show you that I'm very consistent in what I do, my lambda is still called lambda. So what happens? Okay, so if I run, well, let's have a look. Okay, I have to package a JVM, because otherwise it won't work. Let's see what's still. Okay, so I have to package this. Yeah, Scala and Maven, you're so slow. Okay, so now I have a jar file, as you can see. Let's start up the victim. So I'm copying the process ID. As you can see, it just prints out the time like the previous program did. And now I'm going to start the attacker. I've made a little script to make that easy for me. And if I run this, then you see nothing here on the attacking side. But on the victim side, it just works. So I see a question in the...
Just to be sure, the victim is not running anything other than this class, right?
No, that's correct. It's not running anything other than this class. That is pretty scary indeed. So that's also a lot of fun if you have, if you're on a DevOps team, for example, and you have access to the production servers, you can do lots of fun stuff with that. So,
But that is exactly what profilers do.
the guy in the front says that is exactly what profilers do, and that's true. But maybe you don't want to do that in production. So that's all the examples I have for you today. But when I first gave this talk, incidentally, it was in this very venue at the JVMCon at the beginning of this year, a guy in the front said, well, you're just telling us this to create awareness, right? I wasn't, but he did have a point. So what if you want to do something about this, if you want to prevent this kind of thing? So for the first part, where I was playing around with emoji and Unicode, if you want to avoid people messing with that, you should set up your check style and your sonar cube, because those are tools that are really good at catching that kind of thing. However, if you have been paying attention, and I think you have, you know how to avoid check style. So how to avoid avoiding check style? Well, there are two things that you can do. The first one is to set a security manager. So to give you a little demo of that, I'm going to open the time traveler again. And I'm going to install a security manager. Now, if I run this program, it prints the time a couple of times, and then it throws a security exception. because the security manager will catch my messing around and it will prevent it. So that's very nice. I see a question at the front. The guy says it will probably prevent profilers and that kind of stuff. That's true. Even more, it will also prevent Spring. So, you know, and Hibernate and JPA and everything. So it turns out that you can configure a security manager, but that's kind of, you know, you have to make sure it takes a lot of work. So you may not want to do that. Fortunately, there is another option, and that is modularization. Because if you upgrade to Java, well, 11 now, you can use modularization, and when you do that, you will get illegal reflective access warnings when you run your program. And using this compiler flag, illegal access is deny, you can turn the warnings into errors. And that way, your program will just fail whenever you do something that isn't supposed to happen. So that's also a very effective way to deal with this kind of problem. And also, if you want to annoy your coworkers, how fun would it be to force them into upgrading to Java 11 right now? That's going to be fun.
But the illegal access does not happen when you use add-opens.
The illegal access does not happen when you use add-opens, and that is true, but you cannot really do add-opens on libraries that you didn't control yourself. You might, it should be possible to make it work. So, I would encourage you all to try this at home, and I do mean at home, maybe not at work, but it's your call. So, please rate my talk in the app, like and subscribe if you're watching on YouTube. Are there any questions? The last flag that I gave, the illegal access is deny. Will that also work with Hibernate and Spring? To be honest, I haven't looked it up, but if Hibernate and Spring are ever going to support the module system, they will have to make that work. I'm not sure if they're there yet. Other questions? No? Okay, then that's it. Thank you.